Hello everybody, welcome into another lesson and welcome to the very first lesson of Algebra 2 Trig. So, as I said in the welcome video, it's going to start out kind of slow. It's going to seem like Algebra 1 all over again at first, but this is some necessary review. Today's lesson we are going to start out by reviewing how to do linear inequalities. We'll start out with simple inequalities such as what you see here, then we'll do some compound inequalities. So here we have the expression 4x plus 5 is greater than 25. Well, you're going to solve this much like you would an equation. Get the 4x by itself, so subtract 5 from both sides. That would give you that 4x is greater than 20, and then just get x by itself. That would give you that x is greater than 5. So the solution is that x is greater than 5. And then another component of this is we want to graph this on a number line. So if you're ever asked to graph on a number line, here's what you're going to do. And I will demonstrate here very shortly. Let me just fill in some sufficient points. Alright, so now we have x is greater than 5. Excuse me. So notice it's just greater. It's not greater than or equal to, it's just greater. If it's just greater, you're going to put a red dot, not a dot, but a red circle, and you're not going to fill in that dot. That dot denotes that there's a hole there, meaning it does not include 5. It's just greater than 5. And then you'll shade everything going to the right from 5. You'll shade everything going to the right, meaning it's going to go 5 and greater, not including 5. So that's how you would graph that on a number line. I have plenty more examples where this came from. What if then we had 7 minus n is less than or equal to 19? So we have 7 minus n is less than or equal to 19. Well, of course, get that negative n by itself first. So subtract 7 from both sides. You would get that negative n is less than or equal to 12. Now, anyone remember what we do when we have to divide by a negative sign? Because we obviously want to turn negative n into positive n to solve for n. Whenever you have an inequality and you have to multiply or divide by a negative sign, it flips the sign. So this will become n is greater than or equal to negative 12. So you would end up having that n is greater than or equal to negative 12 for your solution. And if you don't believe me, put in any value, put in negative 12 itself. If you do 7 minus negative 12, that's going to give you 19. Well, 19 is certainly less than or equal to 19. If I put in negative 11, that would give me 7 plus 11, which would give me 18. That's certainly less than 19, so that fits. So it flips the sign whenever you multiply or divide by a negative. And now we're going to graph this on a number line. So let's plot some sufficient points here. Because a lot of these you'll not only be asked to solve the inequality itself, you'll be asked to plot these on a number line. So if your solution includes the value, so n is greater than or equal to negative 12, you're going to put a solid dot at negative 12. So you'll actually put a circle. You put in a solid dot at negative 12, denoting that it includes negative 12. And then since it's greater also, you'll shade everything to the right of it, since it's going to be increasing in value. So that's how you would graph that on a number line. Alright. what if we had, so we have 5 minus 2x is greater than or equal to 27. Well, so 5 minus 2x is greater than or equal to 27. So let's get that negative 2x by itself. Subtract 5 from both sides. You would get that negative 2x is greater than or equal to 22. Then, of course, we just want to solve for x, so you got to divide both sides by negative 2. You would get x. And since you divide it by a negative, it's going to flip that greater than or equal to sign into a less than or equal to sign, negative 11. So you end up getting that x is less than or equal to negative 11 for the answer. And then, of course, now we're going to graph this on a number line. You don't have to draw a lot of numbers, you just want to draw sufficient points on a number line to show what you're trying to illustrate. Now, since this is less than or equal to negative 11, meaning the solution itself includes negative 11, you're going to put a solid dot at negative 11. So that'll be a solid dot denoting that it includes negative 11. And since it's less than negative 11, you'll shade every point to the left. You'll shade to the left to denote that it keeps decreasing in value. So that would be the graph of x is less than or equal to negative 11. All right, now what if we have half of x minus 4 is greater than negative 6. So we have half of x minus 4 is greater than negative 6. Well, start by getting that half x by itself. So add 4 to both sides. You would get that half of x is greater than negative 2. And then just multiply both sides by 2 to get x by itself. You would get that x is greater than negative 4. And of course, we only multiplied by a positive number, so the sign does not flip. It stays the same. So x would be greater than negative 4. Now let's graph this on a number line. So let's put negative 4 right here, negative 5. Wait, I'm going the wrong way. There we go. Negative 3, negative 2. Here's negative 5. That's right, I should know that. When you deal with negative numbers to increase, you go backwards. Alright. So this time, it's simply x is just greater than negative 4. There is no equal to, it's just greater than negative 4. So since the solution does not include the number negative 4, you're going to put an open circle at negative 4 and not shade in the circle. You'll just put an open circle at negative 4 to denote that it does not include negative 4. And since it's greater, you'll just shade every number to the right of negative 4 to denote that the values increase. Okay. What do we got next here? We have 3 halves x minus 7 is less than 2. Well, first get your 3 halves x by itself, right? So add 7 to both sides. You'll end up having 3 halves x is less than 9. Multiply both sides by 2, you'll just get 3x by itself. That would be less than 18, which would then give you that x is less than 6. So there's your solution, is that x is going to be less than 6. Now let's plot this on a number line. Let's put 6 here, 5, 4. Alright, so x is less than 6 we want to plot on the number line. Notice there's no equal to part, it's just less than. So since it's just less than, you'll draw an open circle at 6 on the number line. And since it's less than 6, you'll shade everything to the left of that circle, since it's less than. And that would be the graph of that. Alright. We have here 5 plus 1/3 n is less than or equal to 6. So we have the inequality 5 plus 1/3 n is less than or equal to 6. So let's get that 1/3 n by itself, which means you subtract 5 from both sides, so you would get 1/3 n is less than or equal to 1. And then to solve for n, just multiply both sides by positive 3, giving you that n is less than or equal to 3. So the answer is that n would be less than or equal to 3. Now let's graph this on a number line. Let's put 3 here. I'll do 2, 1. Here's 4, 5, 6, and let's do 7 for good measure. Okay. So n is less than or equal to 3. So since there's the equal to component, you'll put a solid dot at 3. So you'll shade the whole dot there at 3 to denote that 3 is part of the solution. And since there's a less than component, you'll shade everything to the left of 3 on this number line. So that's how you would graph n is less than or equal to 3 on the number line. Alright. Different here. So we have 4x minus 1 is greater than 14 minus x. So we have the inequality 4x minus 1 is greater than 14 minus x. So you have the variable on both sides of the inequality. Well, just like you would an equation, try to get the variable only on the left side and get your numbers on the right. So that means you want to remove that negative x from the right, so you're going to add x to both sides. If you do that, you'll get 5x minus 1 is greater than 14, which now we just want to get 5x by itself, so add 1 to both sides. You would get that 5x is greater than 15, which would just give you a solution of x is greater than 3. So x is greater than 3 is your solution. Now we'll graph this on a number line. Let's put 3 here, 4, 5, here's 2, 1, 0. I'll even put negative 1 on here. Okay, there we go. So x is just greater than 3, which means it does not include 3 in your solution. So since it's just greater than 3, you'll put an open circle at 3 and not shade it since it doesn't include 3. And since x is greater than 3, you'll shade everything to the right of 3 to denote your solution. Alright, what's next? So we have negative n plus 6 is less than 7n plus 4. Yeah, that's right. Okay, so we have negative n plus 6 is less than 7n plus 4. So again, you have the variable on both sides. I would say get rid of the variable out of the right-hand side and have it only on the left. So that means you need to subtract 7n from both sides. If you do that, you'll end up getting negative 8n plus 6 is less than 4. Which then, of course, subtract 6 from both sides to get that negative 8n by itself. So you would get that negative 8n is less than negative 2. Now, of course, we just want to solve for n, so divide both sides by negative 8. You would get that n is greater than positive 1/4. N is greater than 1/4 because, again, when you divide or multiply by a negative, you flip the original sign, it becomes greater than 1/4. So n will be greater than 1/4, and now let's go ahead and plot this on a number line. Let's put 0 here, let's put 1 here, put 2 here. Alright, so n is only greater than 1/4. It does not include 1/4. So at the point of 1/4 on your number line, since it does not include 1/4, you'll draw an open circle at 1/4, and then you'll shade everything to the right since it's greater than 1/4. Yes, and it is common to get fractional or decimal answers. You will sometimes have that. Okay. Let's see. 3 more of these type, then we'll move on to compound inequalities. So you have 2 times the quantity of n minus 4 is less than or equal to 6. Well, immediately a lot of you are going to think to do the distributive property, and you can do that. You would not be wrong. But I also believe in the philosophy, work smarter, not harder. You notice both sides have a common factor of 2. You can divide both sides by 2 because 2 and 6 both divide by 2. If you do that, you'll get that n minus 4 is less than or equal to 3. And now you can solve for n by itself by adding 4 to both sides. You would get that n is less than or equal to 7. So n less than or equal to 7 is your solution. Now let's graph this on a number line. So let's put 7 here, put 6 here, 5 here. Alright, so n is going to be less than or equal to 7. So since 7 is included in the solution, since it's less than or equal to, you'll draw a solid dot at 7 to denote that 7 is included in the solution, and since it has a less than component, you'll shade everything to the left of 7. That'll graph your solution on the number line. Alright. So then we have 2 times the quantity of 4 minus x is greater than 8. So we have 2 times the quantity of 4 minus x is greater than 8. And if you want, you could distribute, or so you can see that 2 and 8 both have a common factor of 2, and you can divide both sides by 2. If you do that, you'll get 4 minus x is greater than 4. Which now we want to get that negative x by itself, so subtract 4 from both sides. If you did that, you would get that negative x is greater than 0. But you want to just solve for x, so you got to divide both sides by negative 1. If you do that, you end up getting that x is less than 0, because when you divide by negative, it flips the sign. So the answer to this would be that x is less than 0. Now let's plot this on a number line. So I'll put 0 here, -1 here, -2 here. 1, 2, 3, 4, 5. Okay. So we just have that x is less than 0. It does not include 0. It's just less than 0. So since it's just less than 0 and not including 0, draw an open circle at 0 and then shade everything to the left since it's less than 0. One more like this, then we're going to get into some compound inequalities. Alright, so we have 5 minus 5x is greater than the quantity of 4 times 3 minus x. Well, we have nothing that will divide evenly between the sides, so unfortunately we have no choice but to use the distributive property on the right-hand side. So this will turn into 5 minus 5x is greater than 12 minus 4x once you do the distributive property. And then you have the variable on both sides. Well, obviously we just want to get the variable by itself on the left-hand side, so we need to add 4x to both sides to get it out of the right-hand side. If you do that, you would end up with 5 minus x is greater than 12. And now you want to get that negative x by itself, so subtract 5 from both sides. You would get that negative x is greater than 7. And then you want to just solve for x, so you would get that x would turn into less than -7 since you flip the sign when you divide by a negative. So the solution is that x is less than -7. Let's go ahead and graph this on a number line. There's -8. All right. Alright, so let's graph that x is less than -7. So it's not equal to -7 at all, it's just less than. If there's no equal component and it's just less than, you'll put an open circle at -7, and since it's less than, you'll shade everything to the left of -7. And that's how you would graph that. So these were all simple inequalities, simple linear inequalities. Now we're going to get into compound inequalities. In general, compound, I'm going to write this down here. Compound inequalities use and or, however you want to say it. So they'll use words like and or. Those are compound inequalities. And let me show you what I mean by that, what those are going to look like. So let's say you're given something like -2 is less than or equal to x minus 7, which is less than or equal to 11. So you have that -2 is less than or equal to x minus 7, which is less than or equal to 11. This is an example of a compound inequality. Whenever you see two inequalities fused together like this, it's always using and. Whenever you have an inequality on the left, the variable expression in the middle, and then an inequality on the right, it uses and. So if -2 is less than or equal to x minus 7, that also means that x minus 7 is greater than or equal to -2, and x minus 7 is less than or equal to 11. That's really what that means. It uses the word and, just without saying it. You can fuse them into one. So whenever you see this, it's always going to be with the word and. And when we have the or inequalities, well, we'll get into those at the time. But anyway, to solve these types of inequalities, you're going to solve them much like the others. You ultimately want to get the x by itself. So you're going to add 7 to all three sides to get the x by itself. If I add 7 to negative 2, that's going to give me positive 5, would then be less than or equal to just x if I add 7, which would be less than or equal to 11 plus 7 is 18. So I would end up getting the solution that 5 is less than or equal to x, which is less than or equal to 18. Which also means that x is greater than or equal to 5 and less than or equal to 18. That's what that means. But this is a more convenient way to write that. Now, we're going to graph this. I'm going to skip by units of 5 just for simplicity's sake. I don't think anyone wants to see a really long number line. And you can do that when you're graphing these on a number line. Whatever works for you, as long as it's clear what you're trying to illustrate. So 5 is less than or equal to x. Whenever you have it like this, you're going to start with your 5, and since it's less than or equal to x, you're going to put a solid dot at 5. And then you have x is less than or equal to 18. Well, since 18 is included, you'll also put a solid dot at 18. And then you'll shade the region between 5 and 18. So x is not only 5 and 18, it's every value between 5 and 18. That's what this graph represents. It's not only 5 and 18, it's every value between 5 and 18. And I got more of these compound inequalities. Alright, so we have negative 16 is less than or equal to 3x minus 4, which is less than or equal to 2. Alright, so another compound inequality. You have negative 16 is less than or equal to 3x minus 4, which is less than or equal to 2. So start by getting that 3x by itself, so add 4 to all three sides. If I add 4 to negative 16, I'll get negative 12, which would be less than or equal to 3x, which would be less than or equal to 6. Because if I add 4 to 2, I'll get 6. And then you'll end up having, of course, you want to get x by itself, so divide all three sides by 3. You'll end up getting negative 4 is less than or equal to x, which is less than or equal to 2. That would be your solution. Negative 4 is less than or equal to x, which is less than or equal to 2. So now let's go ahead and graph that on a number line. Alright, so I got my points plotted. So since negative 4 is less than or equal to x, I need to draw a solid dot at negative 4 to denote that negative 4 is part of the solution. And then x is less than or equal to 2. I need to draw a solid dot at 2 to denote that 2 is part of the solution. And then I'm going to shade everywhere between negative 4 and positive 2. So this means that not only are negative 4 and 2 solutions, every value between negative 4 and 2 are also solutions to this inequality. Alright, now what if we shift gears a little bit here? We have that negative 5 is less than or equal to negative n minus 6, which is less than or equal to 0. Well, we know we're going to want to get that negative n by itself, but I'm going to save you a little bit of time here. I don't know about saving time, but it's going to make your life easier. You're going to see why in a minute. If you know you're going to end up having a negative variable in the middle, go ahead, write these as separate and statements. So if negative 5 is less than or equal to negative n minus 6, that means that negative n minus 6 would have to be greater than or equal to negative 5, and negative n minus 6 is less than or equal to 0. Alright, so you're going to see why we did that in a minute. So then get the negative n by itself, add 6 to both sides here. You would end up getting that negative n is greater than or equal to positive 1, and then add 6 to both sides here, you would get that negative n is less than or equal to 6. Now, of course, you want to solve for n, so you have to divide both sides by negative 1. If you do that, you'll get that n, it'll flip the greater than or equal to sign into a less than or equal to sign. You'll get that n is less than or equal to negative 1, and n is greater than or equal to negative 6. So n is less than or equal to negative 1, and n is greater than or equal to negative 6. Which means now, if we can write this as one statement. So if n is greater than or equal to negative 6, that means that negative 6 is less than or equal to n, and then you have that n is less than or equal to negative 1. So your solution would be that negative 6 is less than n, which is less than or equal to negative 1. Now we can graph this on a number line. Alright, there we go. There's my points plotted. So since negative 6 is less than or equal to n, I'm going to draw a solid dot at negative 6 to denote that it's part of the solution. Then n is less than or equal to negative 1. I'm going to draw a solid dot at negative 1 to denote that's part of the solution. And then I'm going to shade everything between negative 6 and negative 1. And that's how you would graph that on a number line. All right. Negative 2 is less than negative 2n plus 1, which is less than or equal to 7. So yes, you actually can have two different types of inequalities in a compound inequality. That is correct, that negative 2 is less than negative 2n plus 1, which is less than or equal to 7. So since you know you're going to have a negative sign on your variable in the middle, go ahead, do yourself a favor, write these as separate and statements. So if negative 2 is less than negative 2n plus 1, that means that negative 2n plus 1 would be greater than negative 2. And then we have that negative 2n plus 1 is less than or equal to 7. Now just solve each of these inequalities separately. So you want to get the negative 2n by itself, so subtract 1 from both sides. You would end up getting that negative 2n is going to be greater than negative 3, and you would then get that negative 2n is less than or equal to 6. Now divide on both of these, divide both sides by negative 2. You would end up getting that n, this would flip the sign into less than positive 3 halves. So n is less than 3 halves, and n would be greater than or equal to negative 3. So n is less than 3 halves, and n is greater than or equal to negative 3. So if n is greater than or equal to negative 3, that means that negative 3 is less than or equal to n, and then n is just less than 3 halves. So that would be the solution here. Negative 3 is less than or equal to n, which is just less than 3 halves. And of course, you guessed it, we're going to plot this on a number line. Alright, so let's go ahead and plot this on a number line. So negative 3 is less than or equal to n. So since negative 3 is included, you'll put a solid dot at negative 3. Then n is just less than 3 halves, just less than, which means 3 halves is 1.5. So at 1.5, you're just going to put an open circle since 3 halves is not included. So you actually have a solid dot and an open circle, and then still you'll just shade the region between the two. So the solution on this, of course, is negative 3 up to 3 halves, not including 3 halves, every value up till that point. So that's what the graph would look like for that. All right. We have that negative 7 is less than 6x minus 1, which is less than 5. Well, this time we have a positive sign on the variable, so we can leave our inequality like this. So just get the 6x by itself, so add 1 to all three sides. If I add 1 to negative 7, I end up with negative 6 would be less than 6x, which would be less than 5 plus 1 is 6. So I end up getting that negative 6 is less than 6x, which is less than 6. Now divide everything by 6. You'll end up getting that negative 1 is less than x, which is less than positive 1. So that's my solution, is that negative 1 is less than x, which is less than 1. Now let's graph this on a number line. Alright, so since negative 1 is just less than x, we're going to put an open circle at negative 1 to denote that negative 1 is not included in the solution. And then x is just less than positive 1, so put an open circle at positive 1 to denote that that's not part of the solution. Then you'll just shade the region between negative 1 and positive 1. So the solution is every value between negative 1 and positive 1, not including those two numbers. Alright. Negative 8 is less than or equal to... No, I'm sorry, it's just less than. I almost screwed up there. Negative 8 is less than 2/3 x minus 4, which is less than 10. Alright, so negative 8 is less than 2/3 x minus 4, which is less than 10. So, of course, get the 2/3 x by itself first, which means I add 4 to all three sides. So if I add 4 to negative 8, I'll end up getting negative 4 is less than 2/3 x, which is less than, so what's 4 plus 10? That's 14. So then multiply everything by 3, I'll get that negative 12 is less than 2x, which is less than 42. Now let's divide everything by 2 to solve for x. I would get that negative 6 is less than x, which is less than 21. So the solution to this is that negative 6 is less than x, which is less than 21. Now let's go ahead and form the graph of this on the number line. Alright, so there's my sufficient points plotted. So negative 6 is just less than x, so we're going to put an open circle at negative 6 to denote that that's not part of the solution. And then x is just less than 21, so you'll put an open circle at 21, and then you'll just shade every value between those, which will show you that the solution is literally every number between negative 6 and positive 21. All right, good. We have here, I have 3 OR inequalities. So here's what they look like. You have x plus 2 is less than or equal to 5, or x minus 4 is greater than or equal to 2. So this is another type of compound inequality, but it uses OR. You're going to get a different graph of the solution. You're going to get 2 disjoint sets. So when you have these, consider each inequality separately. So you have x plus 2 is less than or equal to 5, so solve for x over here. You would just get that x is less than or equal to 3, or then x minus 4 is greater than or equal to 2. Add 4 to both sides. You would get that x is greater than or equal to 6. And that's your solution. You have 2 disjoint sets here for your solutions. So if you put in 3 here, since the solution includes 3, 3 plus 2 is 5, it equals 5. If I put in 2, since it's also less than, 2 plus 2 is 4, which is less than 5. That works. Let's say I try that over here in the x minus 4. I put in 3 minus 4, well, negative 1 is not greater than 2, or equal to it. Even if I put in 2, 2 minus 4, well, that's negative 2. That's even lower. So the x less than or equal to 3 only works for this, for the left equation. And then x is greater than or equal to 6. So if I put in 6 for x minus 4, I'll end up getting, of course, 2, which is in fact equal to 2. If I put in 7, I would get 7 minus 4, which is 3. 3 is greater than 2. But if I put in 6 over here, and x plus 2 less than or equal to 5, I would end up having 8, which 8 is definitely not less than or equal to 5. If I put in 7, I would get 9. 9 is not less than or equal to 5, so you have two separate solutions. And then we do graph them on a number line. And I'll show you. Alright, so we have that x is less than or equal to 3. So since it includes 3, you'll draw a solid dot at 3. And then since it's less than 3, you'll shade everything to the left of 3 to indicate that the value keeps getting smaller. And then you have that x is greater than or equal to 6. So since it includes 6, you'll draw a solid dot at 6, and then you'll shade everything to the right of 6 since it's greater. So notice you have two disjoint sets here for the graph. Very interesting how that works. I have two more problems, then we're done for the day. Let's say we have, so we got 3x plus 2 is less than negative 10, or 2x minus 4 is greater than negative 4. So we have 3x plus 2 is less than negative 10, or 2x minus 4 is greater than negative 4. Well, solve your inequalities, each of them separately first. Get the 3x by itself, so subtract 2 from both sides. You would end up with 3x is less than negative 12, or get the 2x by itself, so add 4 to both sides. You would just get that 2x is greater than 0. And then, of course, solve for x on each of these. You would end up getting that x is less than negative 4, or x is greater than 0. And those would be your solutions. X is less than negative 4, or x is greater than 0. So let's go ahead and graph those on a number line. Alright, so let's start with x is just less than negative 4. So since it's only less than negative 4, it doesn't include negative 4. So you'll put an open circle at negative 4 to denote it doesn't include that. And then you'll shade everything to the left of negative 4 since it's less than negative 4. And then we have that x is greater than 0. So since it's only greater than, you'll put an open circle at 0. And since it's greater, you'll shade everything to the right of 0. So there is the graph of your solution sets on a number line. Alright, one last problem, then we're done for the day. We have that x minus 1 is less than or equal to 5, or x plus 3 is greater than or equal to 10. So another compound inequality, we have that x minus 1 is less than or equal to 5, or x plus 3 is greater than or equal to 10. So we're going to go ahead here, solve each inequality individually. So we'll just add 1 to both sides for the left one. You would just end up getting that x is less than or equal to 6, or Then you have x plus 3 is greater than or equal to 10, so subtract 3 from both sides, you would get that x is greater than or equal to 7. So those would be your solutions, that x is less than or equal to 6, or x is greater than or equal to 7. Now let's graph this on a number line. It's going to look a little weird, especially since 6 and 7 are close together in value. Alright, so let's start with x is less than or equal to 6. So since 6 is included, we'll put a solid dot at 6 to include that value. And since it's less than, you'll shade everything to the left of 6. And now we have x is greater than or equal to 7, so you'll put a solid dot at 7. And then you'll shade everything to the right of 7 since it's greater than. So notice none of the values between 6 and 7 are included. So that's the graph of these. And this is really it for this lesson for linear inequalities. Next lesson we are going to do absolute value equations and absolute value inequalities. So stay tuned for that. I hope everyone has a great day. Take care.